Hi, my name is Todd Rosedahl. I work for we have going. Oh, there we go. Thanks. Here to talk to you about this project and give you a call to action at the end to come and join us. So first of all, LibreBMC. Libre means not free, as in free beer, but free as in open and overt and flexible. And so we're trying to free up actually the hardware that constitutes that BMC. There are a lot of people involved. Tim Ansel from Google is involved. Michael Gilder from Antmicro. We have many other companies as well that are involved in this project as we try to open up the BMC hardware itself. So what we're doing as a prototype and proof of concept is we're taking the AC922. That is a big server that is developed by IBM. It's at Oak Ridge in Livermore. Was one of the top supercomputers in the world for a while. And what's nice about that particular platform is everything in it is already open source. So it runs OpenBMC. There's a self-boot engine on there that kicks the chips off and initializes everything. That's completely open. So everything in all the software in this system is completely open. What's not open is the BMC. So we all know the BMC has a baseboard management controller. It's used to initialize, power up your system, all your out-of-band management via IPMI or Redfish in the future to collect sensor information. But it is also an attack vector. If bad actors can get in there, they can start interacting with your BMC and do bad things. So we're trying to tighten up that security. So how we're doing that is we're removing the card that is in the AC922 that has an A-Speed AST2500 on it. We're taking that BMC card out and we're replacing it with a card from Antmicro, developed by them, that has an Artix A7 FPGA on it. So we're going to take that, instead of that A-Speed, we put an FPGA. Now we have complete control over what that hardware does. And we're doing everything in the open. It uses the OpenPOWER ISA that has been opened up by the OpenPOWER Foundation years ago. It's using that OpenCore microwatt. All the peripherals are going to be open as well with LightX, so LightETH, whatever the peripherals are out there that are on, inside that gateware on the FPGA will be open. And of course, it will run that same OpenBMC load that was running on the actual A-Speed chip on in the system. And the goal would be it does everything that actual ASIC could do. It boots it up. All of the interfaces are supported. Currently, we're not there. We do have some pieces are running, but there's a lot more work to do. We have a lot more FPGA code to write. We need to get all of the OpenBMC stack running. But that is the goal of this project. And we are going to support, of course, the DC-SCM standard, which is, you've been hearing a lot about that today. So the good thing about this, and why it's so valuable, is you can inspect that. Now the ASP2500 has a root of trust on the chip, but you can't really see it, right? It's not open. You can't look at it and see what is this hardware doing. Now with this FPGA, you can look at every single thing and say, you know exactly what your hardware is doing as well as all of your software. And if there was a problem, and you think about Spectre Meltdown, which of course is on the processor chips, but we had clearly a security hole there, had to put a lot of expensive and resource-intensive software solutions in. Had that been an FPGA, if we would find a problem here, a security hole, we can roll a new FPGA image out there to the field of the existing hardware and fix that. We can add security enhancements even before we found problems, right? That we can, as the security threats evolve, we could evolve right along with it and change that hardware. This is targeted to be no more expensive than the actual ASIC. We think it'll be the same price or even less. So I don't think there's a cost problem here with the FPGA. We just need to prove out a lot of the performance issues. We need to flesh out all the functionality. And that's the next step in the project. So here it is installed inside the actual AC922. And if you had a chance to see the booth, we just had this up. I had all the hardware here, and you could play with it and see how it connects in. But this is it now installed. We had to create an interposer card. The the AC922 did not support the DC-SCM standard. It wasn't out when that was created. So we had to make an interposer card so that this card could slide in, the DC-SCM card could slide into that interposer and then connect to the chassis. So the call to action is join us on this project. Everything is completely open. You don't have to sign any NDAs, CDAs. You can just join and listen. All of it's out there recorded. If you want to see past meetings, we meet twice a month. There's one at 10 a.m. and one at 5 p.m. so that we can support multiple geographies. And if you go to the virtual booth for the OpenPOWER Foundation, you'll see this pitch. You can click on these links. One interesting thing to note is you can now buy your own AC922 for less than $5,000. So that's an extremely expensive system when it was put out. Now, it doesn't have any GPUs in it, but you can buy one for under $5,000 and play around with this, by yourself. So that's pretty cool. So yeah, come out there, check out the virtual links, and yeah, come on and join us. So that's it. Any questions?
Thank you. That was great. I have one question.
Yeah.
You did say that the FPGA you can, in the field, upgrade and program.
Right. Yep.
Which interface do you plan to use to do that?
I don't know. Tim, do you know the interface to be used?
The question I have, is it actually the RJ45 interface or system interface?
Well, you wouldn't go in band to do it. You would go out of band to update the FPGA for sure. If that's the question. Yeah.